Welcome to this really brief mini project where we're going to investigate the different types of network performance which can be gained when using an instance directly, when connecting to the instance, using CloudFront, and then also using Global Accelerator. So these are products which you might use to improve network performance, specifically different types of applications. So CloudFront is a cache that can be used with HTTP or HTTPS, whereas Global Accelerator is a network acceleration product which utilizes the AWS Global Network to provide optimized network connectivity between your customers and your infrastructure. Now, in order to illustrate this, we're going to do things slightly differently. First, you'll need to be logged into an AWS account with admin permissions. If you're using my courses, then you can use the I am admin user of the general AWS account, so the management account of the organization. If you're not using my courses, then you just need to use any identity within an AWS account which has admin permissions, but it should be a dedicated training account. Now, normally, whenever I do any of these mini projects, I have you pick the Northern Virginia region. What I want you to do for this is pick a region which is fairly spread geographically from your actual location. So I'm based in Brisbane, Australia, and my home region is AP Southeast 2. So I'm going to go ahead and pick a region which is fairly distant from where I am. I'm going to pick Canada Central, so CA Central 1. You should pick something, ideally, that's a different part of the world from where you are. So if you're based in the US, you might want to pick AP Southeast 1 or 2. If you're based in Europe, you should pick something that's either in the US or Asia Pacific. Once you've selected a region, go ahead and move to the EC2 console. Now, attached to this lesson is a full set of text-based instructions which you can follow along to as you move through this video. But let's move back to the AWS console, specifically the EC2 console, and click on Launch Instance. Under Name, type WordPress, and we're going to launch 3 individual instances, so change number of instances to 3. Under Application and OS Images, go ahead and type WordPress into the search box and press Enter. And then locate WordPress certified by Bitnami and Automatic. It should be the top one listed. Make sure it looks like what's on screen now, and then click on Select. Now, this is a subscription in the marketplace, but it is eligible for the free tier. So you can go ahead and click on pricing and just make sure if you expand WordPress, it's one that's listed for $0 per hour for the actual software itself. Now, you can ignore the fact that a T3A.small, which is the vendor recommended instance type, is listed at a cost because we won't be using that. Just make sure it says $0 per hour for the actual subscription itself. Once you've done that, you can close down this expander and click on Continue, and then scroll down. For instance type, we're going to pick a free tier eligible instance, so pick T2.micro or whichever is listed as free tier eligible. Under key pair, select Proceed without a key pair not recommended. Then scroll down. Under Network Settings, click Edit. We're going to pick the default VPC. And then to ensure that all 3 instances are started in the same subnet, go ahead and click on the subnet drop-down and pick one specific subnet. It doesn't matter which one, just pick one subnet so we can eliminate AZ variations from our network performance tests. Make sure that under Auto-Assign Public IP, it's set to Enable. Under Firewall Security Groups, make sure Create Security Group is selected. Then scroll down and you can delete the SSH rule at the top, so click on Remove next to SSH. We need to keep HTTP. We can delete the HTTPS rule, so click Remove next to HTTPS. And then we're going to add an additional security group rule. So click on Add Security Group Rule, change the type to all ICMP IP version 4. And then under source, type 0.0.0.0/0. So this makes sure we can ping this instance from any IP version 4 address. For production, you might lock this down significantly more, but for this mini project, this is okay. At this point, everything's good, so go ahead and click on Launch Instance. Now there might be a pause here while it's subscribing to the Marketplace AMI. In fact, you might actually get an error saying that it's taking longer than expected. If you do, that's okay. Just go ahead and click on Instances and you'll need to wait until all these instances change from pending to running. Now this might take some time while the subscription is approved. Even though the subscription does come under the free tier, it can take a few minutes to approve. So pause the video and wait for your instance state to change from pending to running. Now once your instance states are running, we're going to rename these instances. So expand this column and click on the edit icon next to the first instance and change it to WordPress-standard and then click on save. Then do the second one and type WordPress-global accelerator and click on save. And then change the third one to WordPress-CloudFront and click on save. Now at this point, go ahead and wait again until the status check changes from initializing to 2 out of 2 status checks on all the instances. So pause the video and wait for that to occur, and then you're good to continue. Once you have 2 out of 2 checks passed on all 3 instances, then go ahead and pick WordPress-standard, copy down the public IP version 4 address into your clipboard, open a new tab, and then type http:// and then paste in the IP address. It might show as insecure depending on your browser, but that's okay. All we need to make sure is that it shows a blog entry, because that signifies that the instances are working. Next, I want you to go back to the AWS console because we're going to configure Global Accelerator. So type Global Accelerator into the search box at the top and open that in a new tab. Then click on Create Accelerator. For accelerator name, it's going to be WordPress, and it's going to be a standard accelerator. We don't need to change anything else, so go ahead and click on Next. And then for listeners, we're going to listen on HTTP, so that's port 80, with the protocol being TCP, and then click on Next. For region, select the region where you just created those EC2 instances. In my case, CA Central 1. You'll need to pick your region. This is really important. Pick the region where you launched those EC2 instances and then click on Next. Click on Add Endpoint. In the drop-down, change it to EC2 instance, and then click in the Endpoint drop-down and select the WordPress-Global Accelerator instance. And once you've done this, click on Create Accelerator. Now that's going to take a few minutes, so next we need to create our CloudFront distribution. So type CloudFront into the search box at the top and open that in a new tab. Go to that tab, Create a Distribution. Now in the origin domain box, we need to put the public IP version 4 DNS name of the WordPress-CloudFront EC2 instance. So go back to the EC2 console. Select WordPress-CloudFront and copy down the public IP version 4 DNS into your clipboard. Then go back to CloudFront, paste that in, and then press Enter and click Elsewhere, and that will change the options that are available to those that are relevant for a custom origin. Once they've changed, click on HTTP only for protocol. Scroll down, under Default Cache Behavior, select No for compress objects automatically. Under Cache Key and Origin Requests, change the cache policy to caching disabled. Change the origin request policy to all viewer, and then scroll down and click Create Distribution. Now we're going to need both the CloudFront distribution and the Global Accelerator to be ready before we can continue. So pause the video, wait for both of those to finish provisioning, and then you're good to continue. Okay, so now both of those have completed. The first thing is to make sure we can reach all 3 of our endpoints. So first, select WordPress-standard and copy down the public DNS IP version 4 address into your clipboard and open that in a new tab. So this is connecting directly to one of the EC2 instances. Then go to CloudFront and copy down the domain name for CloudFront and open that in a new tab. And then go to the Global Accelerator console and copy down the DNS name and open that in a new tab. So now we have connectivity to all 3 of these endpoints using the DNS names. So now I want to move across to my terminal and show you the differences in network connectivity or network paths between these 3 different endpoints. So first I'm going to copy down the DNS address of the direct EC2 instance into my clipboard. Then I'm going to open a terminal and I'm going to type traceroute, and then I'm going to paste in this DNS address. And if, like me, you've pasted in the URL, you'll need to delete the last / and then delete http:// from the start, and then just press enter. Now this is going to show you the path from your local machine through to this EC2 instance. And if it's anything like mine, because I'm going from one continent to another, it's going to have a large number of hops, and in my case it has over 200 milliseconds of latency. So that's a relatively long route for the traffic to flow through. Now I'm going to cancel this because it's not showing a number of the hops, but you get the general idea. It's showing at least 23 hops and over 230 milliseconds. Next we're going to try the same, but with the DNS name of the global accelerator. So move back to the command prompt, type traceroute, and then a space, and then we're going to use some additional options, so -I, and then space -Q1, and then the DNS address of the global accelerator. Now the reason for these options is beyond the scope of this mini project. In this case, just go ahead and press enter. Now you'll notice this time the traffic route is significantly different. Now you'll note there's much less hops, only 11, and it shows 13 milliseconds. Now that's because this is terminating at a local edge location. So in this particular case, this would mean much improved performance because my traffic enters the AWS global network much sooner, and this has much better performance and much more optimal routing than the general public internet. Now the same thing occurs if I do a trace route through to the CloudFront distribution DNS name. This too uses a local AWS edge location, in this case one in Sydney. So this shows 12 milliseconds access time, so with an error margin pretty similar to the global accelerator, and this too is using a local edge location. Now this is a Sydney, Australia based CloudFront edge location. In my case, this will differ for you if you're in a different location. Now to illustrate exactly what effect this has, I'm going to use a different browser. So I'm going to open Google Chrome. I'm going to use an incognito window and open the developer console, and then I'm going to dock this console to the bottom of the screen and click the network tab and then disable caching entirely. And what I'm going to do next is open up the DNS name of a direct EC2 instance. And this will show the traffic overview, the amount of data and the time taken for the various different components of this page load. Specifically, if we look here, we can see the initial connection took 237 milliseconds, and then it was waiting for a response for 337 milliseconds. So this is direct to the EC2 instance located, in my case, in the Canada region. So Australia to Canada means a 237 milliseconds initial connection, and then a 337 milliseconds waiting for a response. Now let's contrast this by if we open up Global Accelerator, and then look at this value again. Notice how the initial connection is only 13 milliseconds and the time waiting for a response is 500. So if this page load was bigger and more complex, it would start loading faster because this initial connection is made to a local edge location. And the same is true if we open this web page using a CloudFront distribution. Again, the initial connection is relatively quick to make because it's to a local edge location, and the connection takes a similar amount of time to get a response, so 500 milliseconds. Now you generally wouldn't use CloudFront and Global Accelerator in the same situation. CloudFront is a cache and it's generally used for HTTP or HTTPS traffic, whereas a Global Accelerator is a more general purpose network accelerator tool. But you can see they both offer the same type of improved network performance by utilizing edge locations, and in the case of Global Accelerator, the efficient transit across the AWS global network. Now that's everything I wanted to cover. What we need to do now is tidy up all of the infrastructure. So go back to the CloudFront distribution, select it, click on Disable. That will take some time to complete and we need that to be disabled before we can delete it. So move across to the Global Accelerator console, select the Global Accelerator and then click on Delete. You'll need to first click on Disable Accelerator and that can take some time, so we need to wait for that to complete. In the meantime, go to the EC2 console, select all of the EC2 instances, click on Instance State and Terminate and confirm that termination. Move back to Global Accelerator because that's likely the first one that's going to be finished first and we can see it's been disabled. So confirm the deletion and then click on Delete. Just check on the CloudFront distribution, it's still deploying the disable operation, so we can't move on with that yet. Move back to the EC2 console. All of those have finished terminating. Type Marketplace into the search box at the top and move to Marketplace Subscriptions. Click on Manage below the WordPress subscription. Click on Actions and then Cancel Subscription. Confirm and then click Yes, Cancel Subscription. And that will cancel the subscription to the Bitnami and Automattic WordPress AMI. Then let's go back to the CloudFront console, hit refresh. We need to wait for that to complete, so pause the video, wait for it to change into a fully disabled state, and then we can continue. That's finished, so select the distribution again, and then click on Delete and confirm that deletion. And that's the infrastructure back into the same state as it was at the start of this brief mini project. Now in this brief mini project, you've implemented two different types of network performance improvement using CloudFront and the Global Accelerator, and we've had the opportunity to look at how this influences performance, both using the web console and using a trace route. Now these are the type of services that you're going to use in production to improve network performance. So while this was a fairly simple demonstration, this will give you some idea of how you can utilize these products in the real world. Now at that point, that's everything I wanted to cover in this mini project. Go ahead and complete the video, and I hope you'll join me soon in another exciting mini project.